In these notes, we're going to examine the graph of an exponential function just to see what it looks like and define some important pieces on that. So please make sure you get your heading on there, including the assignment and page number, and the title of the notes, which would be Intro to Exponential Functions. Please make sure you pause the video if you need to. We're just going to start off with a quick summary of a basic function. So can you write for me basic exponential functions? Just realized I spelled this wrong, so we're going to fix that. Basic exponential functions are written in the form y equals a times b to the x power. Make sure you pause if you need to. When we have an exponential function, you're going to have your x as your exponent, and you might have something in the front of your base, but it would be in this form. So what we're going to do is we're going to practice just to see what these look like using our calculator, and then we're going to get into some specifics of graphing it. So the directions, if you could write, sketch the graph of each. We're just going to do 2 practice ones, and we're going to rely on our calculator. So for example A, can you write y equals 2 to the x power? If you want to know if it's in this form, this is the same as y equals 1 times 2 to the x power. Your imaginary a is 1. So I'm going to go to my calculator and I'm going to go to y equals, and I'm going to type in y equals 2 to the x power. Let me cover this up. So 2 to the x power. I'm going to make sure my graph looks okay, so I might have to adjust it. So I'm going to hit graph. And if you take a look, what it does is it curves, and it's just barely hovering over this x-axis. It's never going to touch the x-axis, and then it swings back up. If I was to zoom in a little bit, I'm going to change this to -5 and 5, just to get a better idea of what it's looking like. It's just hovering right above. So what I'm going to do is just make a quick sketch of it. So I'm going to use my ruler. So I have my x and y axis. And I'm just going to draw this shape on my paper. So it's just hovering above. It's not touching it, not quite. And then it swings up. I want you to notice the y-intercept. The y-intercept is actually, if I look at my table, you notice that when x is 0, we have 1. So our y-intercept is 1, which is actually this number in the front. We'll do one more of these practice ones, and then we'll examine even further. Can you write for me y equals 1/2 to the x power? And again, this is the same as y equals 1 times 1/2 to the x power. So if I grab my calculator and type that in to get an idea of what it looks like, I'll go to y equals, type in 1/2 to the x power. Notice I put the 1/2 in parentheses. If I hit graph now, notice it's going the other way. It's going down from left to right, and it hovers just above the x-axis. So I'm going to go ahead and draw that little sketch. So I've got my axes drawn. And my graph went down from left to right, so it went here. And it hovers just above the x-axis. Never touches it, just hovers right above it. You'll notice also, if I go to my table, my x-intercept, or my y-intercept again was 1. And that is this one right here. So what we're going to do is summarize now what we just saw, and then we're going to graph our functions. We're just, if you're using line paper like I am, we're just making sketches, but we're going to make it as accurate as possible. So I'm going to switch to the next page, and we're going to write some important information. So I'm going to write important info on exponential functions. Important info on exponential functions. I abbreviated that. So we've got a few things to write down. So here's one thing. If we have an exponential function, it's going to be written in the form Now remember on the front of our notes, we had y equals a times b to the x power. That's exactly what we're going to write. So y equals a times b to the x. But we could have a plus or a minus at the end of it. So we're going to put plus k. This helps us to shift up and down. The next part, can you write increase? That means goes up. When b is greater than 1. So if you noticed on the front of the notes, our b was 2, which is bigger than 1. That's why it went up. It's going to decrease when it's in between 0 and 1. Like this was a fraction between 0 and 1. So we're going to put a little bullet and write decrease when. And you're going to put 0 is less than b is less than 1. That means our b value is in between 0 and 1. So it's a fraction or a decimal between 0 and 1. And our example again, if we had 1/2, that's between 0 and 1. That's why it decreased, it went down. So over here on the side, just so you can see, this is our increasing function, and this is our decreasing function. Next, can you put 1-to-1 functions? And what that means, it's going to pass the vertical line test and the horizontal line test. So I'm going to put in parentheses, passes vertical and horizontal line test. And I'll explain what that means. Passes the vertical and horizontal line test. So if I was to take my function and draw vertical and horizontal lines, it's only going to touch it once every single time. That's considered 1-to-1. One little note left. Can you write y-intercept is when x equals 0. So we looked at our graph for that. And I want you to put something for me. Can you write y-intercept is a for y equals a times b to the x. So this is our a value. When you have this equation, that first number in front of your exponent, your power is your y-intercept. Your y-intercept is a plus k for if you have y equals a b to the x plus k. And I'm just going to underline these. You're going to notice on an example we're going to do in a second, we're going to have the y-intercept as adding instead of just the number in the front. So we're going to do 2 examples and we're going to answer 3 questions for each of them. So what I'm going to do is I'm going to divide my paper into 3 sections towards the bottom. So I'm going to have 3 sections and a little heading going across, kind of looking like a table. Can you put over here, this is example C, can you write y equals 7 times 3 to the x? We're going to put example D in a minute. We're going to answer 3 questions for each of them. So number 1, I'm going to put over here, y-intercept. So what I want to do is find the y-intercept of this graph. So I'm just going to graph it just to have an idea. So I'm going to go to y equals, and I'm going to type in 7 times 3 to the x power. And I just want to look at it. I'm going to switch my window back for a second. I'm going to hit graph just to get an idea. And it's going up. Notice because our number next to the exponent is greater than 1. Our y-intercept looks like it touches it pretty high up. If you look at the notes from up top, the y-intercept is when x is 0. So what I'm going to do is change my x to 0 here. So I'm going to write y equals 7 times 3 to the 0 power. Well, we learned previously that anything to the 0 power is 1. So that's the same as 7 times 1, which is 7. So our y-intercept is 7. If I go to my table, just to double check, if I go to 0, notice I have 7. That's my y-intercept. Part 2 of this, we're going to decide if the function's increasing or decreasing. So can you write increase or decrease? Increase or decrease? Well, we could do this a couple of ways. We can look at the graph and see what's happening from left to right, or you can look at the note above. It is increasing when that b value, the base attached to our exponent, is greater than 1. It's decreasing if that base is from 0 to 1. So if you look at our example, this is our base, 3. 3 is greater than 1, so it's increasing, it's going up. If I was to go to my calculator and hit graph, notice it's increasing from left to right. So we're going to put increase or increasing. Last part, we're going to sketch the graph. Sketch the graph. So I'm going to make a tiny x and y axis. And we're going to label our y-intercept, but I'll show you that in a second. So we're making our x and y axis. I'm going to draw this little graph. So here's what my graph looks like. And I'm going to label my y-intercept, which was 7. So I'm going to make this curve as best as I can. Hovering above the x-axis, not touching it. Going up. And I'm going to put my point as 0, 7. So there's my sketch. We're going to do the same thing for one other example, and then we're done with the notes. So for example D, can you write y equals 1/3 to the x power plus 4? So this time we've got something added to the end. First thing we're going to do is find the y-intercept. So remember, the y-intercept is when x is 0. So we're going to change our x to 0, and then we'll check it. So we have y equals, instead of 1/3 to the x, it's going to be 1/3 to the 0 power plus 4. Remember that anything to the 0 power is 1 according to our exponent rules. So this is going to be 1 plus 4, and that becomes 5. If I want to check this in my calculator, remember we also said if we have an equation in this form, our y-intercept should be the number in the front of our base plus the number at the end. Well, the number in the front of the base was just an imaginary 1, and we have a 4. 1 plus 4 is 5. I'm going to go to my calculator and type that in really quick. So I have 1/3 to the x power plus 4. If I go to my graph, here's what it looks like. And to check to make sure that's the right y-intercept, 0 is with 5, so that's my y-intercept. Number 2, increasing or decreasing. Well, if you look at the graph, you can already tell it's going down. Also notice that the number as the base is between 0 and 1, so that means it's going down, it's decreasing. So if you have a fraction attached to your exponent that's less than 1, it's decreasing. Now we're going to sketch our graph. So we're going to draw what we saw in our calculator. So I'm going to make my x and y axis. I'm going to draw this little shape, and I'm going to plot my y-intercept, which is 5, remember. So I'm going to make a graph going down because it's decreasing, hovering right above the x-axis, and that point is 0, 5. So that's your basics on exponential functions. Please make sure that you submit this assignment into Canvas to get credit.